Hey everyone, this is Marcus. Welcome to the video version of a tutorial I wrote called Dynamic Decentralized Data, how to build a factory pattern in your smart contract and index search its infinite events with subgraph templates. A little bit of a mouthful with that tutorial. I know we're going to cover a lot here. If you have any questions about this tutorial, go ahead and go to the description. It's going to have GitHub links. It's going to have different links to resources that you might want to use. It's also going to have a link to the written version of this tutorial, all of which are going to be helpful for you. This tutorial is for Web 2 devs looking to get into Web 3 and understand a little bit more about blockchain coding, Solidity, specifically, as well as how to gather blockchain data through subgraphs and a special feature within subgraphs called subgraph templating. A little bit about subgraph templating. This might interest you if you have a factory pattern smart contract that is able to produce children or proxies infinitely. You want to potentially index those children and be able to search them dynamically without having to update your subgraph. That's really what we're going to be building today. If any of this sounds interesting, awesome. You're going to have a good time today. And if you have any further questions, go ahead and find me on Twitter. Marcus_Rain, REIN, is my Twitter handle. And just hop in there. You'll see the link to my Twitter down in the description as well. Reach out, tell me how you like this tutorial. I'm here to help and be of value to you. So let's get into it, guys. Before we dive into the code, what I want to do is go over a high-level overview of exactly what we're going to be building today. So let's go ahead and dive in. We have the main file that we're going to be working with. It's going to eventually take in two dependencies. We'll talk about those as we're actually coding. I want to talk about what's down here. This is the real meat of what we're doing. We've got two smart contracts we're going to be writing and deploying from actually the factory.sol. We have the first smart contract that we're going to make. This will be the child smart contract, also known as the implementation smart contract. And this smart contract will be the reference for the factory. The factory will use this as a reference and say, hey, factory, I want to make a smart contract and I want to make a lot of them. Which one should I make? And this will say this one right here. All the logic inside this one will be copied a heck of a lot into children. All right, that factory pumps out all the children that it wants. So as this interaction is occurring, it's referencing here and pumping out all of these children. That's amazing. One small thing to realize is all of the data is being held in these files, in these smart contracts. And that's awesome because the actual transfer of data is minimized. All of the calls made on these smart contracts will be made by a delegate call referencing the logic in this very 1.0 implementation contract, this first contract. That keeps gas cheap. We like cheap gas. And from there, we have all of these smart contracts being used by all of these users. Amazing, 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 already deployed on the blockchain. How do we actually get that data? Well, what we do is we look at graph protocol subgraphs, and those subgraph templates, specifically a singular template that we will write, will be able to dynamically find every single address that is brand new that comes from this factory. If this factory pumps out a brand new address, this subgraph template does not have to change. It simply knows what's going on and will be able to index whatever is happening on every single other smart contract created to infinity and beyond. So, of course, that leaves a very useful data set for users to say, hey, we've got this very, very interesting smart contract factory pumping out all of these little children all the time, referencing this upgradable smart contract. And let's say you want to make version 2, version 3, version 4, that factory can read that, no problem. From there, that graph protocol subgraph template will say, no big deal, I gotcha, and we can gather all that data. So that's what we're building today. And if you're feeling lost about any of this, go ahead and go into the description. There's going to be more links about the factory pattern as well as upgradable contracts, as you can see with this idea here. And if you have any further questions, feel free to reach out and also check that list of information that I provide below. Let's get into coding. Welcome to Remix. Remix, for those developers who do not know, is a code editor that allows for really efficient development in the Solidity language. If you don't know a lot about Solidity and would like to learn more, go to the description. The description will have all that you need for learning Solidity as well as learning Remix. Once you've learned, or if you have already learned a lot about Solidity and Remix, let's start building. First things first, let's get a workspace together. We're going to have it be a default workspace, and we'll name it Tutorial for Factory Patterns. You can name it whatever you like, of course, and it's going to populate as such. Now, we have these 3 files already populated. We can just delete those. We're not going to need those. And all we're left with is storage.sol, which is just fine. Let's rename this to our... Let's go here and say factory.sol. That's the one that we want. That's the one that we're going to work with all day today. So first thing after we have factory.sol is we're just going to clear all of this out. We're going to leave the SPDX license identifier and the pragma solidity. Those are just fine. And we're going to start building our first contract, child. Our child. Child, please remember a message upon initializing. That would be awesome. Now remember, what we have initially is an implementation contract that our factory contract will reference, and that's going to be the child that we're going to write in a second. And if you have any questions about children and implementation contracts, all of that, please go to the description. You'll get more information there. Child, please remember any message updates. That would be awesome. We want to update the message if we can. And then child, please go ahead and keep a tally of how many times you've updated the message. So those are the functions this smart contract will have. So now that we have what we want our child to do, let's go ahead and build that as such. So we're going to have our contract child be able to, remember the 3 things we have here. Please remember a message upon initializing. Okay, we can do that. String public, and we're going to have a default message at first. And default message. That's all we're going to call it. That's simple enough. And let's go ahead and it's going to be able to initialize and remember a new message. And anytime you initialize this contract, this default message will update. Let's make that a function. Initialize, and it's going to take a string memory message and public initializer. We have this modifier here, and we'll talk about that a little bit more in a second. Message equals, oh, not plus, oh, nope. Message. There we go. All right, so message equal message. When we have a smart contract that is going to be referenced by a factory contract, we want that smart contract to initialize, and that will only be able to be done once based on this modifier here that we're going to import in a second. And the purpose of that, please go ahead and read the documentation down in the description for the logic behind that. Let's go ahead and import that function from OpenZeppelin. Boom, boom. And we have initializable.sol. So we'll take that. Contract is initializable. And right now we have a little contract that can really, all it can do is when it starts, it will actually update this message. And that's awesome already. But remember, we need to remember any message updates. That's the next thing we want this little child to do. So child, could you please do that? That would be awesome. Let's write that out. Function update message, and that's going to take in a string, and this is going to be able to be called by anybody who's anybody, and we want this message to equal the message. There we go. And also we want this to keep a tally. Wouldn't that be nice? Okay, so updated message, we'll call it tally, and we'll store that upstairs in just a second. So we'll just add right there. We actually have to do another variable here. So what we're going to do is uint 256 be explicit updated message tally equals 0. All right, simple enough. So let's go over this real quick. What we have here is a default message that's being stored. It's going to initialize every single time, well, excuse me, one time that you actually run this implementation contract to begin with. And it's going to have, after that, a updated message capacity every single time you update it. It's going to actually update that message tally from 0 to 1 to 2 to 3. And every child will have this functionality, all right? But now, how do we actually know that this is going on? It needs to actually emit an event. It actually needs to tell everyone, hey, look what I'm doing. I am updating my message. I am an awesome little child. So let's go ahead and define an event right here. And it's going to take a message that was updated and also tell the world about updated message tally. And every single time that this occurs, it should actually emit. And it's going to take in message and updated message tally. Simple enough. We are flying. All right. So to review, we have a child that is initializable. It's going to be able to be an implementation contract that runs once and once only. And it's going to store at default a message, and it's also going to store an updated message tally, which is 0. You are going to, upon calling this contract, initialize this contract and give it a message. And this message is going to be stored and replace this default message right here. Amazing. Now, once this has been done, anytime a message is updated, it's going to also update that message again. Every single time it's going to tally that message again, and it's going to emit a message updated event. All of this is going to be done a lot on the children that come from this template. So let's go ahead and start to build our factory that will take this child contract and make a million zillion infinity little children. Before we get going too much into the factory contract, I want to talk about EIP 1167, which is the clone factory foundation. And so if you want to create clones or copies or factory pattern contracts, basically lots of little copies of any smart contracts, that might be gas intensive. It might cost a lot to do that, especially making calls on each of them and not delegating calls as this allows. So we want to be able to implement this standard to have our smart contract factory be as affordable as possible. And so if you'd like to read more, feel free to read more about that. All that we really need to do is go to the GitHub repo down here. It is called github.com clone factory, optionality, clone factory. And from there, you'll go to contracts. And bam, we have the clone factory.sol, and this is the EIP 1167 standard, and the whole screen won't show it. How about this? I will just I'm not going to do that. I'm going to take it here, copy, and then let's bring it into the IDE. If you copy it, and then from there, you're going to go ahead and create a new file under contracts, and we're going to call this clone factory.sol, and you're just going to copy paste it right in there. All right, and so beautiful. We've got the clone factory ready to go. You can see that beautiful bytecode that's going right there. It is wizardry. You do not necessarily have to know too much about this, but what we need is create clone. And where do we want to create the clone? It's going to be this address, target. We will take this target address and then create a clone of it. So before we go on any further, go ahead and read up more about the clone factory if you would like. You can go through all of this good stuff, EIP 1167. There's plenty of tutorials about this also if you want to dive deeper, but we don't have to do that today. Let's just keep on building in Remix. Let's go back to factory.sol and make our factory a clone factory. Okay, so let's get building our factory. First things first, this factory is going to need to take in the clone factory.sol details, all of those functions, specifically create clone. That's the one we're looking for. So let's import that right now in our factory.sol file. You're going to go to the top here, import clone factory.sol. So now all of those functions from clone factory are being imported into factory.sol. Let's keep building. What do we want our factory to do? Good question. We want our factory to do a few important things. Factory, please keep a list of all children you've ever made. And then also, according to that, now that we have the list, factory, can we create a getter, basically get a list of those children. And we're not going to call it a list, we're going to call it an array. Let's be proper. And get that array. There we go, a little bit of grammar cleanup. But now we want those children, we want to keep that list and then get that array. We want to keep an array and then get that array. That's two things we want that factory to do. Next thing we'd like that factory to do. Factory, can you import the address of the implementation contract you'd like to copy or clone, more specifically. Factory needs a reference, and that's going to be the implementation contract that we're initially going to create. So that's going to be important there too. And then finally, the most important, factory, can you create or clone a child? That would be great. So let's get to building all of these little things right now. And one more thing I want this factory to do. Can you emit an event when you've created a child? That would be great. Let's, not exclamation point. Let's go ahead and build out this factory. First things first, we want to keep an array of all the children we've ever made. So we'll do that right here. It'll be a child array, and we'll name it public children. Simple enough. Done. All right, now factory, can you get that array of those children? Okay, let's create a getter. All right, function get children, and that's simple enough. And it'll be external view, and it'll return the type returns of the child array that we've built, and it will actually get that. We have to, because this is an array, it has to be coming from memory, and it will simply return the children. All right, so it's going to return the type of child, and that's the array, and it will take all of those children, that variable right there, and boom, now our get children is created. Very cool. So next, we want to import the address of the implementation contract we'd like to clone. Let's build that. First things first, let's create a blank variable, and that's just going to be updated upon the implementation contract's importing of that address. And we want to do this right when the smart contract spins up. So let's make that a constructor, which will run right at the beginning, and it will take in an address of the parent, or let's actually name that more accurately, implementation. And let's say the implementation is equal to the implementation, and that needs an underscore, and not the parent. Let's do implementation. That's it. So we have this implementation dialed in where the address is going to be empty right there. That implementation is empty. And the constructor runs right when the factory runs, and it's going to take in the implementation contract at first. It's going to run it once, and then from there, we have our implementation address to actually go ahead and then initialize. Cool. So from there, let's keep on building. What else do we want it to do? We want to finally create the clone and then emit the event of the clone. So let's go ahead and do that as such. Function create child. All right. And it's going to, when we have to remember what in our child, do our children do? They actually need a message. If you go to the top here, remember our child, it needs to take in a message, and it has the ability to update that message as well. So it's going to be taking those in. That's all our child will do. And you're free to actually build out much more functionality in the future for your smart contracts if you would like. But for this one, all it's going to do is create a child, and it's going to take a message, and that's going to be coming from the memory, and this function is going to be available to everybody, and it's going to be of the type child. We'll name it child, and let's go ahead and create that clone. Remember the EIP 1167? That's what we're doing here. So create clone, create clone, and that's going to be of the implementation that we've imported. So that is a big one right there. We have the child of the type child contract, and we're going to create a clone all the way through and import that implementation as such. So coming through, next, we want to initialize the child, and it's going to take that message and bring that message into that child right there. And then finally, we've got that child with that message inside. Let's go ahead and children.push, push that child to the children right up there. Okay. Now, finally, we've got all that ready. That's amazing. Finally, we need to actually emit an event when we've created a child. So let's go ahead and build that as needed. So we're going to have an event, and that's going to, let's call it child created. And it's going to need a few things. I would like to know the date when the child was created. I'd also like to know the message in that child. And then also I'd like to know the address of that child. That's going to be a big one. The actual address on the chain when it was created. And let's go ahead and emit that. So emit child created. This will be indexable by that subgraph that we're going to be building. And let's see, block timestamp. That's going to be good. Essentially, this is available at all times. We do not have to import that. That block timestamp is there. And let's just bring it in there. So that's going to be our date that we like. And also, we want to bring in the message. And then also, we want to bring in the actual address. And that's going to be the address of the child. So we're going to have to typecast that. That'll be the address child. Bam. Okay. So right now we have kept an array, and we actually got that array. We've imported the address, and we know exactly what we want to do right here. And then finally we have the ability to clone that child. So all in all, I think we have a pretty good little factory pattern built up here. We got the factory. It actually has the initializable capacity. That's going to be really cool. And all the way through, we're ready to go. Oh, one small thing I forgot right here, that this also needs to be the create clone. We actually have to bring that in here. So that's going to be is clone factory. Bam. That actually allows that create clone to run, and that's going to be a big one there. So please add that in at the very end. Now we have the create clone. If you just save it, it will be ready to rumble. Very cool. We got some errors right here. What are we doing here? Oh, this is the address upgradable problem. Yeah, so that's okay. Yes, it actually does just fine. I don't know why that was showing right there. No errors, and we've compiled it, and it's ready to go. Awesome. Cool. So I do apologize. There was a very small error when I was compiling it before. If we go to the compiler and run right through, it was having some difficulties here. And so go up to the top right here, and it's only this small change. It just needs to be more updated into a more recent version of Solidity, and that is all it needs. So let's go ahead and continue building out this thing with that error corrected. Okay, so now that we have our smart contracts ready to deploy, let's go ahead and do just that. We're going to go ahead and go to Remix VM, virtual machine. London is just fine. And we're going to use this for testing before we deploy. Let's go ahead and do this in the correct order. So we need to first deploy our child. All right. And that's actually going to be deployed very nicely. It is going to be the implementation contract that we talked a lot about earlier. And remember, on the implementation contract, we have to initialize it. So we're going to name this, we're going to give it a string, implementation, and we'll initialize it as such. Okay, very cool. So that went through. We can see our transaction went through, and all that detail is in there. Very, very nice. And there it is. It has the decoded input of implementation. So we know it went through. And now we want to actually deploy our factory. Now, our factory is a little bit different in that it's going to need, as you can see right here, a implementation address. And so let's go ahead and grab that address right here. We know this is the implementation that we want. We'll copy that and bring that right into here. And now, because our factory, as you can see right here, is actually asking for that implementation address, it has to be there to deploy it. Bam. We have it, and now it's in the green. We've got that ready to rumble. So now let's minimize that child. We have the child, which was the implementation contract, and the factory. Let's go down here, and that factory is now referencing this child and ready to create all the children it wants. Very, very cool. So let's create our first child from our factory and say child number 1. That's going to be our very first child, and let's create it. Boom, it's pending, and all right, we've got a child, and very cool. So let's go down here, and if we say, hey, I want to understand which, how many children we've done, what's the addresses, you just click that, and you can see that's the address of our children. Very cool. Let's do it again. Let's go ahead and say, create child number 2. We've got another address, another child coming through, and just for funsies, let's go ahead and say we have child number 3. All right, and if we get children, boom, 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 we have lots of children right there. Now, wouldn't it be cool if we were to actually interact with any of these children? Let's go ahead and look at child number 1 and look at that address, and right there we'll copy that, and let's go to the very top here and let's deploy this address as a child. So if we go here, we have a child, and it's going to be able to deploy it. Let's not just deploy it here. Let's deploy it at the address. Let's actually just reference it right there. And let's go down here. If I just click that, boom, we have the... Now let's update this child's message. And let's say child 1 updated message. And that's going to be the update message for that child. Cool, we've updated the message. That worked just fine. And if we call that message... All right, that is right there. So we actually can see, if we go down here, it's not gathering that. That's okay. Child 1, there it is, child 1 updated message. So we have that in there. Very cool. Let's go ahead and take a look at child number 2 and update that message as well. We're going to be creating this data because I want this to eventually be able to be, let's go all the way through right there, eventually to be able to be run on the blockchain. And we're just testing out everything to see how that works right now. So let's go ahead and take that address that we just copied. We'll paste it right there. And now we have another child that we have previously deployed from the factory, and we cannot initialize it, but let's update this one message. Child number 2 updated message. And bam. All right, so now we've got all that ready to go. And it's all working just fine. So what I'm going to do is actually do this exact same sequence all the way through and deploy this on the injected provider MetaMask. And so I'm going to inject the provider. I'm going to put this on Gorelli, if I'm pronouncing that correctly. I believe I am. We're going to deploy this on Gorelli, and then from there, we're going to build our dynamically updated subgraph with a template feature. So go ahead and tinker around with this if you'd like a little bit more, but first and foremost, go through it, make sure your smart contracts are working, make sure that's all functional, and you do that in that order, and then deploy to whatever test net you would like. I'm going to do Gorelli, and from there, we can start building our subgraph. Okay, so what I have done so far is I have just taken the time to do all of these transactions on Gorelli, and that took a little bit longer, of course, than just doing it in the virtual environment. But if you go ahead and look at the factory right here, you've seen I've created child number 5, and I could actually look at my factory and identify the address of child on the array, the very first child right there, that's child 0. I can look at child number 1, I could look at child number 2, and we're going to be using that actually to go through and actually create our subgraph. We also can get the whole array of our children right there if we want. I've done a lot of work right there. It took a lot of time. You're free to just tinker around and do that yourself if you'd like. And this is the very first child, and I updated the message twice. And I'm just going over this because we're going to be able to index all of this in a subgraph very soon. So I've made all these children, each with their update messages, update child 3, update message. Let's do update message 2. And you can see I've built all this data. I've made these transactions. So they're on the Gorelli blockchain right now, the testnet. And that's really cool. The very cool thing is now let's transition, after we make this transaction, let's transition into making our subgraph, into giving it the template functionality to index not only a static address, such as this factory, but also any children and any events that occur from any child created. So let's go ahead and do that right now. Okay, so now that you have built all of this incredible code and deployed everything onto your testnet, let's go ahead and index it with subgraphs. If you haven't been to thegraph.com, go to thegraph.com, and what you're going to do is go to Subgraph Studio. You'll connect your MetaMask, and from there, you can go ahead and get going. So we're going to create a subgraph together. And we're going to name this live tutorial. No, it's too long. Live tutorial, and we'll say not factory pattern, but SG template. I like that. And we know we deployed on Gorelli. I'll pronounce that correctly someday. And right now we have everything ready to go. So if you haven't already installed the Graph CLI, you'll do so like so. Just npm install graph protocol, Graph CLI in your terminal. And then we're going to initialize our subgraph. So let's go ahead and do so right now. We'll go open the terminal and initialize our subgraph. Boom. And it's going to spin up. Thinking, there we go. We know we're going to be on the Ethereum blockchain, and it's going to be the live tutorial SG template. That's the slug that we had right in here, and that's right up there. So it did that correctly. And then also we're going to create a folder that's going to be done so, and then we're going to go to the Gorelli network. That's what we want. Bam. And then initially what we're going to do is the main contract is actually the factory contract. So if you remember right there, that was going to be right here. All right. So we have that factory contract right there. Let's copy that. And from there, we will go back into here and bam. Now it's not going to be able to get the ABI from Etherscan. That is A-OK. Guess what? Let's go back to here. And we will go into the code itself and say, hey, we want the factory and we want that ABI. So we'll copy that ABI. And then from there, we will create a new file and we'll call it factoryabi.json. It is a JSON. And we'll just paste that right in there and we'll save. And now we have the ABI file saved on our actual local hard drive. We will copy that path. We'll bring it in. Bam. And we'll name this factory. Bam. And we want to index the contracts as events. Yes, please. And it's going to build our subgraph. And that's really nice. It's going to say, hey, we know all the data we need. We're going to install the dependencies and do it cleanly, quickly, and effectively. And subgraph.yaml, as you'll see, has the imported initial factory contract that we have, and that's right here. This is that factory contract. and all the information is brought in and created for us. And this next one is the child contract, as you can see, and it has that address. So remember what we're trying to do here. We're trying to actually look at the order of things that have occurred. Let me rephrase that. We initially put out a implementation contract that was the child contract, and then from there we gave that child contract, the factory was referencing that initial implementation contract, and then turned out a lot of these children. So this hard-coded child address is not going to be the most helpful. We need this to be dynamically created, and that's where templating comes in. So let's go ahead and do that right now. First thing, a little bit of housekeeping. We want to index the blockchain from a specific point forward. We do not want to index all of the blockchain on Gorelli. We just want to see the initial smart contract we deployed, which was this child implementation contract, and we want to index from that location forward on all those blocks, not all of the blockchain, just on this location. So let's find the implementation contract. What we're going to do is go to this address. Let's go to Etherscan, and this is actually the factory contract. You could see how this is the factory contract because it created lots of children, which is great. We don't want the factory contract because that wasn't the very first implementation contract. Remember, before this was the implementation contract. So let's go to the Etherscan Gorelli. Remember, it's a test net, and find the implementation contract and see which start block it deployed on. There we go, and there it is. So initially there was a contract creation that occurred 31 minutes ago on this block. So we're going to copy that, and we're going to bring that into our actual, let's see, there it is. We're going to bring that into here, all right? And we're going to put that as start block, boom. So that is the first location that we want to index from, and it's going to gather everything that we need. Let's continue on. So we have all of this information here, and we think, okay, maybe this is all that we need. Maybe this is everything that we need. I think we need to actually change a few things to make this actually a template. So let's go ahead and do that right now. And subgraph.yaml, as you'll see, has the imported initial factory contract that we have, and that's right here. This is that factory contract, and all the information is brought in and created for us. And this next one is the child contract, as you can see, and it has that address. So remember what we're trying to do here. We're trying to actually look at the order of things that have occurred. Let me rephrase that. We initially put out a implementation contract that was the child contract, and then from there we gave that child contract, the factory was referencing that initial implementation contract, and then turned out a lot of these children. So this hard-coded child address is not going to be the most helpful. We need this to be dynamically created, and that's where templating comes in. So let's go ahead and do that right now. First thing, a little bit of housekeeping. We want to index the blockchain from a specific point forward. We do not want to index all of the blockchain on Gorelli. We just want to see the initial smart contract we deployed, which was this child implementation contract, and we want to index from that location forward on all those blocks, not all of the blockchain, just on this location. So let's find the implementation contract. What we're going to do is go to this address. Let's go to Etherscan, and this is actually the factory contract. You could see how this is the factory contract because it created lots of children, which is great. We don't want the factory contract because that wasn't the very first implementation contract. Remember, before this was the implementation contract. So let's go to the Etherscan Gorelli. Remember, it's a test net, and find the implementation contract and see which start block it deployed on. There we go, and there it is. So initially there was a contract creation that occurred 31 minutes ago on this block. So we're going to copy that, and we're going to bring that into our actual, let's see, there it is. We're going to bring that into here, all right? And we're going to put that as start block, boom. So that is the first location that we want to index from. And it's going to gather everything that we need. Let's continue on. So we have all of this information here and we think, okay, maybe this is all that we need. Maybe this is everything that we need. I think we need to actually change a few things to make this actually a template. So let's go ahead and do that right now. Okay, so now that we have our subgraph.yaml with the start block, we're going to actually take in the template alterations into the subgraph.yaml, and then we'll have the CLI be able to actually generate some templates for us. So it's very simple to make a template. All you got to do is templates. That's it. From there, we also have to delete the hard-coded address for our children because remember, they're dynamically going to be created. So that's deleted. And from right there, we've done the hard work at saying, hey, this is the template that should be dynamically created every single time a child is created. Please index this event subgraph. It's going to look at the event initialized and message updated. And it's going to be able to help us out that way. So let's go ahead and go to our terminal, and we're going to graph code gen, and that's going to actually create a generated file for us. You should see it pop up here in just a second. There it goes. Boom, 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 boom. There it is. Templates. And we have a child.ts template, which is really, really cool. All we need to do is, remember, this is an auto-generated file. Do not edit this directly. You can just check out what's going on here. It's all the stuff that we created. The message updated. It's looking for these events that have occurred. And from there, we have to say, okay, well, now that we have our actual template ready, we got to go and give it things to do, which is going to be really, really cool. So what we're going to do is we're going to go to factory.ts, and that's going to be in our src file. And this is the logic that our actual factory.ts is going to have. And every single time our factory does a create child, it's going to actually dynamically pass the actual address into that template that we created. So we have to do that right now. So import, and this is going to be our child. And that's going to come from we have the generated, and that's going to be the templates, and that's where it's coming from. And I've been writing a lot of solidity. No semicolons. From there, we are going to actually say, hey, once the event is emitted, we have this function, handle child created. It's going to actually assign the date, param1, child address, and it's going to just take all the metadata from the event and just assign that to our actual new little kid. And then right there, we want this address to also be passed. So we need to reference create event params child address. We have this child that we've imported, this template, and we're going to create a new child, but we have to pass in the address that was actually emitted from this child created event. And this child created event actually contains the address of that new child that's been created. So this child template is going to create a new template that will automatically populate behind the scenes into this subgraph.yaml file, where you can see this child does not actually have an address. But guess what? Templates dynamically will accept those new addresses that are being created in the factory import. So factory child import. So really, really cool. You do not have to update your subgraph once this has properly been set up. All of those children that will dynamically be created with new addresses will automatically be indexed by this little logic right here and this single line right there. Very, very cool. From there, we should be able to actually run this subgraph. So let's go back here and do the graph code gen and graph build. And what that's going to do is take all the work we've done here and all the work that we've done thus far and get it ready for deploy. Very nice, very nice, very nice. Boom, build is completed. Very cool. Let's go back to our Subgraph Studio And let's go ahead and deploy it like so. We'll copy that, bring that in. And if everything goes well, we should have our subgraph deployed. So version 0.0.1, that's fine. And let's see it do this live. This is always exciting. Should see this pop up. There we go, compiling subgraph. Bum, 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 bum. Bum, 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 bum. Uploading. That's nice. And build completed. Deploying to graph node, and it's live. Cool, there it goes. So because we did the smart block at a good time, its progress is really almost already done. And now we can start playing with our data a little bit. There we go. It's already synced. It's already indexed all of what we need on Gorelli. And let's go to the playground. And it already, I love the playground, it already has some of the things, some of the events, some of the functions already here. And it emitted this information. If you click right here, you could see some other things that we did. You can see how all of the GraphQL is lined up nicely. I want to see all the message updated as well. And let's just have the first, I think 10 is great. And I want the ID, I want to know the message, and I want to know how many times each of those children have updated their messages. So let's run this, and bam, we've got it. So we can see right now on the blockchain, we've got the address, which is awesome. From this actual event, a child-created event was emitted, and this was child number 5, the date, and you can actually get that converter and convert that date into actual readable date, and it actually has the time there too. Very useful information. We can see all the different times and all the different things that we're going. Create child number 1, create child number 3. Let's see if there's any message updated too. We just go right through the timestamp, ID, all of that. Let's see, update message, there it is, message updated. So pretty much I request it right here with this GraphQL. This is the query, and this is the data. So I hope this was helpful. If there's any questions about any of this, please reach out to me at Marcus_Rain_ on Twitter. I'll be there hanging out, trying to help you guys out as much as I possibly can. But I just want to congratulate you for doing something that was really, really cool. We had this, let's do a high-level overview of everything we did. Very impressive work from everybody who followed all the way through. This is what we built, guys. So we had this factory.sol, and we had it deploy 2 contracts. We had the implementation contract and the factory contract that was the parent, and it referenced this. And then we deployed it to infinity. We had a lot of smart contracts deployed. And then we built a graph protocol subgraph template. And now we're getting the useful blockchain data popping out from this subgraph on the playground right here. So awesome work, everyone. And keep on building, keep on learning. And I really hope this was helpful for everyone. All right, take care, everyone. Bye.